All right, next up is the discussion of speed and velocity. So, what is speed? Speed is the rate of motion. So speed is how fast we're moving. How fast or slow something moves is our speed. To find average speed, we take distance over time. So speed, distance over time. The units for speed, meters per second. Now, like distance, speed is always positive because there's no direction associated with it. So, for example, a kingfisher is a bird that catches fish by plunging into water from a height of several meters. If a kingfisher dives from a height of 7 meters with an average speed of 4 meters per second, how long does it take for it to reach the water? Our equation is speed, distance over time. So, things that we know this is our speed, and we know this will be our distance, so we're solving for time. A couple different ways to solve this. I'm going to show you a quick way, and that if we put speed over 1, we can just do a quick cross multiplication. So let's substitute in 4 for speed over 1 is equal to 7 over t. We cross multiply. 4t is equal to 7, and we divide both sides by 4 to get our answer. So when we take 7 divided by 4, we get 1. Ooh, went too far there. We get 1.75, and our units are seconds. So 1.75 seconds. If we want to round to sig figs, actually 1.8 seconds is probably more accurate. Look at another example. So we ride our bike 1 kilometer at 10 kilometers, or 1 kilometer 10 kilometers per hour, and another at 1 kilometer at 30 kilometers per hour. So we're going a little bit faster there. What is your average speed for the 2 kilometer trip? Is it greater than, less than, or equal to 20 kilometers per hour? Now to do this, we have to do a little bit of work because we know speed is distance over time, but we got to look at this and this as separate situations. So we know distance and we know speed. So we're going to solve for time for both A and B. So for A, our speed is 10, and over 1, our distance is 1 kilometer over t. So it's going to be 10t is equal to 1. We divide by 10. T here is 0.1 hours. Okay, so this took 1/10 of an hour, the first one did. We look at the second one, and we do the same equation, speed, distance over time. Our speed is 30. Our distance is 1 over t. So 30t is equal to 1. Divide both sides by 30. T is going to be 1 over 30, which when we look at it, to find a decimal answer, 1 divided by 30 is equal to 0.03 hours. Okay, and that's the time it takes to do this. So our total time, when we add these two together, our total time is going to be, it's going to be 0.13 hours. Our distance traveled, all right, is 2 kilometers. So speed is distance over time. Our distance is 2, and our time is 0.13. So I just take 2 and divide it by 0.13, and I get a speed of 15.4 kilometers per hour. So is it less than, greater than, or equal to? It's definitely less than. But you have to do this. You have to find it for each separate situation and then bring them back together. You'll have some problems with this on the homework. Average velocity. So the difference between velocity and speed is velocity is based off of displacement in time, which means velocity is also in meters per second. But velocity, being a vector, okay, always gives us a direction because it deals with displacement, which also is another vector. So it's how fast something is moving and the average direction in which the object is moving. Okay? If it's moving in the positive direction, so to the right, has a positive velocity. If it's a negative direction to the left, it's going to have a negative average velocity. So athlete sprints 50 meters in 6 seconds, stops, and then walks slowly back to the starting line in 40 seconds. If the direction of the sprint is taken to be positive, what are the average sprint velocity, the average walking velocity, and the average velocity for the complete round trip? So, velocity, displacement over time. Okay, the D is going to mean displacement here. Let's look at A when he's sprinting. Okay, so velocity is going to be distance, 50 meters in 6 seconds. For B, the average walking velocity, again, he walks back to where he started, 50 meters in 40 seconds, okay? So let's look here first and do the math. We take 50 divided by 6, and we get 8.3 meters per second. Now we said we're going to take the direction of the sprint to be positive, so it's going to be positive 8.3 meters per second while sprinting. Now when he walks back, we take 50 divided by 40, and his velocity walking back is going to be 1.25 meters per second. But since he's walking back to the left, it's going to be a negative velocity. So C, we want to know the average velocity for the round trip. Here's where things get a little easy or maybe tricky. It depends how you look at it. But velocity, remember, is displacement over time. What's our displacement? Well, if we start here and we walk 50 meters and then we walk 50 meters back, our displacement turns out to be 0 meters. If our displacement is 0 meters, our velocity also is 0 meters per second. So our average velocity for the complete round trip is 0, even though when we sprinted it was 8.3, and when we walked it was negative 1.25. So, speed and velocity, the difference is speed, rate of motion. Velocity gives rate and direction. Speed, always positive. Velocity can be positive or negative. The sign gives direction. And then lastly, for speed, the greater the speed, the faster it goes. And the same thing with velocity. If we talk about the higher the number, the faster the object's going. That part's the same. Speed, scalar, velocity, vector.